Hello everyone, I'm Asyraf and I'm here to present my project, 3-dimensional Cnc-based agricultural robot for automated monitoring and water spraying of button mushrooms. In Malaysia, mushrooms, or particularly button mushrooms, are popular but require intensive care. Efficient and sustainable agricultural methods are essential to address issues like water wastage, high operational costs, and labor intensity. This project uses CNC technology to create an agricultural robot that automates monitoring and irrigation, measuring efficient water use and better crop yield. For problem statement, current agriculture lacks automated systems for precise monitoring and targeted irrigation, leading to inefficiency and high cost. CNC-based robots can solve these problems, especially for urban farmers with limited resources. Therefore, the objective for this project is to develop the complete hardware of a 3-dimensional CNC-based agricultural robot with a spraying system, to design a plant spraying system for the CNC-based agricultural robot to provide targeted irrigation for identified plants, and to evaluate the performance of the agricultural robot in terms of task completion. The scope for this project includes create a 3D CNC-based robot for monitoring and watering button mushrooms, monitor a 50 cm x 50 cm crop area, use a user interface for controlling the robot, use 3 stepper motors for robot movement, integrate a water pump for automatic watering, and install a webcam for button mushroom detection. This hardware uses an Arduino Uno microcontroller, a CNC shield, stepper motors, a water pump, and a webcam. The Arduino IDE software is used for system code development. The block diagram illustrates the design and operation of the robot. The power source supplies power to the Arduino Uno microcontroller and CNC shield, which control the hardware components. A laptop connects to the Arduino Uno for processing commands. The CNC shield and Arduino Uno work together to control the stepper motors and water pump, enabling precise monitoring and watering of button mushrooms. The system flowchart shows the robot's operational flow. It begins with initialization and user interaction. The user selects either crop monitoring mode or crop spraying mode. In monitoring mode, the robot moves the webcam to continuously monitor the crop area. In spraying mode, the user inputs coordinates and the robot moves accordingly, prompting the user to activate the water pump if needed. The system ensures efficient monitoring and watering based on user commands. The prototype design phase involves modeling the robot's structure and component placement, ensuring durability and mobility within a 50 cm x 50 cm crop area. The design aims for efficient monitoring and irrigation of button mushrooms. An experiment was conducted to evaluate the performance of the 3-dimensional CNC-based agricultural robot. A 3-dimensional CNC-based agricultural robot for automated monitoring and irrigation in button mushroom cultivation was successfully developed. The robot's hardware works seamlessly within a 50 cm x 50 cm crop area. The software interface allowed precise user command input and control. Experimental results confirm the robot's effectiveness in reducing labor, conserving water, and enhancing crop yield. There are some recommendations for future work, such as enhanced error detection system, the scalability, autonomous navigation, energy efficiency, and IoT integration. By addressing these areas, the robot can be further improved to meet the evolving needs of modern agriculture, contributing to sustainable farming practices. That's all from me. Thank you.